Hello programmers, back to another problem solving video, and today I will discuss about the h-nong problem, which is 1 prime. So here in this problem I have to calculate prime numbers basically. So here it says given a number x, determine if the number is prime or not. So here you can find a lot of prime numbers from 1 to 100 actually. So there are those prime numbers from 1 to 100. And what is the number of number x here? So the x limit is 2 to 10 to the power 5. Okay, so I can use integer data type. So if the number is prime, print yes, otherwise print no. Okay, so let's get started. For example, I take 5 because 5 is a odd number. Sorry, prime number. 5 is a prime number. 7 is also a prime number. Okay, so for 5, just take the value from the user. Okay, so the input part is done, and I need a function because I will solve this problem using function. So write cout is prime. So this is the function name, and I just pass the variable x to it and write an end line after it. So here I will write the function here. So if, sorry, the return type is boolean, so is prime, receive the value which is passed from here, so integer x. After that, if x is less than 2, that means uh, number 0 or 1. If x is 0 or 1, then returns false because those numbers are not prime numbers. And now what conditions I will write, like if any even numbers, if any even numbers I receive, then just return false because even numbers are not prime because it is divisible by 2 always. So if x is divisible by 2, just return false. Okay, and also if x equal to, just return 2 because 2 is a prime number. So I write three conditions here. After that, I have to run a for loop for integer I is equal to 3. Why 3? Because I already calculate 0 and 1 for in this condition, 2 in this condition. Okay, since I already calculated 0 to 2, so that's why I start from integer I 3. And what will be the condition? I into I less or equal x, then I plus is equal to 2. Okay, and here I have to check x modulus I equal 0 or not. If 0, that means this is divisible, then return false. And if none of the conditions met, then just return true because this number is prime number actually. So what I did here actually, so this algorithm calls sieve of erratorsness. Okay, this algorithm called sieve of erratorsness, sorry, erathosthenes. Okay, so here basically I hope you already understand up to line number 8. So you need to understand this thing, basically this for loop. Here I start from 3 and I just increment plus is equal to 2 and run this loop square root x. Okay, I don't need to run until I is less than x because square root, calculating square root is enough. And this is this algorithm takes needs to elaborate briefly because you will not understand in short times. So for now, I just what I can say that this algorithm the time complexity of this algorithm is square root of n, And why? Because I just write I into y. This is the condition. That's why the time complexity of this algorithm is square root of n. And why I plus plus? Because I value is 3 and I plus plus the next I value is 5, and the next I value is 7, the next I value is 9. Basically I just taking the odd numbers, because in line number 8 I already written false for all even numbers, so I don't need to calculate for even numbers, because all even numbers are not prime numbers. So I just return false, and I have to calculate only odd numbers, because odd numbers can be prime, can be not prime. So that's why I just uh, write a for loop for all odd numbers, and if the odd numbers is divisible by I, then returns false, and this is not, if this is not the case, just return true. Okay, and the loop will run square root of x. Okay, so you can write using sqrt function, but sometimes it will give errors, because this error comes from precision error. You will learn more about it when you will start exploring on number theory. Okay, so if you start number theory uh, topic, then you will learn a lot of thing uh, of prime, modular arithmetic, and others. Okay, so let's for now just compile this program. So here I get 1, that means 1 is a prime number. So what I have to print actually here, yes or no? Okay, so what I can do, if this condition returns true, then just print yes, otherwise print no. So build and run it, so it returns yes. Okay, so if I take, sorry, if I give number 4, obviously it returns no. Yeah, it returns no. Perfect. So just submit this problem, sorry, submit this solution, submit. Running on test 32. Okay, accepted, alhamdulillah. Okay, I end up this video here. See you on the next one, which is palindrome. Okay, till then, tata, bye bye.